It's all on the paper. Hi, my name is Cameron Feldman, and today we're going to be going over the correlation coefficient, or as my friends and I call it, R. Now, correlation coefficient measures strength of correlation. It can be from -1 to 1. The closer it is to -1 or 1 will determine the strength of the actual correlation. If the correlation is positive, that means as the x increases, so does the y. And if it's negative, that refers to as the x increases, y decreases. Let's look at some examples here. First, we have r equals -0.2. Now, this is further away from -1. However, it is still negative, which means it is a weak negative correlation. Here we have r equals 0.96. This is very close to 1, so it is a strong positive correlation. And here r equals 0. This is very rare. However, when r equals 0, that means there is no correlation. Let's look at a problem that you might find on an FRQ. Here we have a graph, our x and y variables, and we see the data plot. Now, the question is, which represents r? 16, -0.92, 0.73, or -0.01. Immediately, we can cross off 0.73, since it is not positive. Also, we can cross off 16, because it's not in the range of r. Now we are left with -0.92 and -0.01. The obvious answer is -0.92, as this is a straight line and is very strong. So the answer is B. Now, if you're going to want to solve this using your hand and paper, you're going to want to follow this instructions. The formula for R is n, which is the amount of data points, times the sum of xy minus the sum of x times the sum of y, all over the square root of n times x squared minus the quantity of the sum of x squared times the square root of n, the sum of y squared, minus the quantity of the sum of y squared. Now that seems like a lot of work. Instead, we can just use our easy calculator and solve it. For example, if we are given a data set as shown and it asks us to find r, we simply have to go to stat, edit, oh, it's already there. Here we have the data points where L1 represents the x and L2 represents the y. Next, we go back to stat and go to calc. We scroll down to 4, which is a linear regression line. Once we have all of our information in, we enter until we go to calculate. Here it easily shows us that r is -0.983. This is Cameron Feldman signing off.